Hello everyone, welcome back to the channel. So in today's video we will cover Pandas end to end. Pandas is one of the most versatile tool that you will be using as a data professional. Maybe you are data analyst, data engineer or data science in any field of data. Just like SQL, Pandas is also versatile, right? Everyone will be using Pandas because Pandas is used for data cleaning, for aggregation, for joining data from multiple sources. You can do literally everything whatever you do in SQL using Pandas as well. So Pandas is going to be very important and we will cover end to end in this video, and at the end of the video we will do a mini project where we will read a JSON file, convert this into Pandas data frame and load data into a SQL in a star schema format, like we have orders table and dimension table, right? So it is going to be very exciting video. Please watch end to end, practice yourself. All the links will be there in my description box to get the files and notebook and everything. Okay, so let's start. Okay, so these are the topics that we will cover, and we'll cover everything about Pandas. You may be working as a data analyst or data engineer or data science. You need only these topics to learn in the Pandas, and that's it, nothing more than that. Right? So we will cover with basics of Pandas, right? How to create data frame, right? How to read data from CSV, Excel, JSON, right? What is the difference between series and data frame? Then we will see data selection, how to select particular columns, rows, how to filter data, how to filter null values, right? How to manipulate data, adding column, updating column, deleting column, how to sort data, rename columns, change data types, how to clean data. We will see how to handle null values using drop NA, fill NA, how to remove duplicates, right? Then we will see how to work with date and time functions, like if you want to extract year, date, or want to find the difference between two dates, right? Then we will move on to the aggregation, how to aggregate data, how to get, for example, category wise sales, city wise sales, or aggregation on multiple columns. So we will cover all of that. Then we will cover important topic of joining, how to join data, right, using different kind of joins, or how to do union, right, how to append data, kind of union in SQL, right? Then we will see how to work with databases, right? So databases is important one in your day-to-day work. You will be most of the time working with databases. We will see how to read data from a SQL database and how to write data to a SQL database, how to run update, insert commands, everything we will see, right? And in the end we will do a small project where we will use request module to fetch live weather data. The response of this API will be a JSON, so we will have to convert that into a Pandas data frame, and then we will load data into MySQL. So we will do a mini project so that you get a good hands on. Okay, great. So let's start. If you don't have Pandas installed in your system, so first you have to install Python. So you can go to Google and install Python if it is not there in your system. After that, just open the command cmd command line and you install Pandas, you install notebook, and you say python -m notebook. Once you do that, the Python notebook will be opened in a browser. So for example, in this browser it is open right now. Wherever you want to create your Python file, you can go to that folder, right? So for example, I have created a folder Pandas tutorial under documents. There I have two files. I will use these files during the session. So I have kept it here, and here only I will create a new file, right? So it will open in a new tab. Once it is there, you can just rename it. So we will say Pandas tutorial. You can give any name, right? Great. So now your Jupyter notebook is ready. You can write any Python code here. For example, a equal to 2, print a. So now once you write a code, you can run it using this run cell command, right? So it will run it. Another option is you can press Control Enter. So that will also do it, right? And every time to run it, this cell number will increase. So it is 2 now. I have done twice. So for example, again, if I say print a here, right, and if I run it, it will say 3 now, right? If I run it again here, it will be 4 now. So we will know the sequence, which cell has run first and then which cell has run later, right? So this is the basic how you will work on the notebook. Okay, so once you are ready with your Jupyter notebook, we will you can start coding, right? So let's go through the document and read what is pandas, right? So pandas is a powerful Python library used for data manipulation, analysis, and cleaning. It's especially useful when you are working with tabular data like Excel or SQL tables, right? So pandas you will work whenever you have a tabular data. It is very SQL like language. The operations that we do in SQL, similar operations can be done using pandas, right? You can load and inspect data, clean it, filter and manipulate it, analyze and aggregate it. So all of these things you can do using pandas. Okay, so what we will do, we will go ahead and create our first pandas data frame. A data frame is just like a table, you can imagine, right? So I have created a data structure here, right? So if you have to create a pandas data frame from a data structure, this is how you can create. So this is a dictionary. If you see, if you know little bit of Python, this is a dictionary, right? In this dictionary I have key value pair. So key is name and value is a list, right? It is in a square bracket and this list has three elements. Similarly, we have another key age and it has three elements, right? So what does it tell? It tells that this data has two columns, name and age. First row is Sumit and age is 25. Then Rahul, age is 30, Ankit, age is 35. So once you create this data in this form, right, you can just say df equal to pt.data frame and you pass this data. Now before that we will have to say import pandas as pd, right? So this is a general convention that you rename pandas as pd, right? Generally on all the code you will see that pd as alias is used. You can use anything as such, but pd is generally used, so you should use pd only. Okay, so now there is a method data frame. What you have to say, pd.data frame and pass this dictionary, that data, right? And then what I will say df, right? You don't have to say print in Jupyter Notebook. Even if you just say df, it will show you the whatever is there in the df, right? So I have run this. So if you see, we have a tabular structure, right? We have name and age, right? And this is a index basically. So index starts from 0. We have not created this index, so this will be created automatically and it will start always from 0, 0, 1, 2. Okay. Now let's say I want to add one more column, so I can just add one more key value pair here. So for example, let's say salary, right? And salary is, let's say, 25,000, 30,000 and 35,000. Right? Now, if I run this, you will see we have three columns now, right? So each key is a column, right? And also the number of values in this should be same. So it has three in this list. We have three elements here, also three here, also three. Now, what happens if I add one more here? So let's see. So it is giving me error. The error is all arrays must be of same length, right? Array means list, right? In other programming languages, you will say array, but in Python, generally we call it list. So what it is saying, when you are converting it to a data frame, the number of elements should be same. Here we have three, but here we have four. So that's the problem here. I will change it back to three, right? So this is how you can create a data frame from a data structure, right? Generally, we get data in form of JSONs from APIs. So we will have to convert that data in something like this. Once that is done, then we can pass it to pd.dataframe and data frame will be created. Okay. Now, generally, apart from API responses, if you are reading data from somewhere else, let's say SQL or Excel, you will directly read data in pd.data frame, right? You don't have to create this kind of structure and then you don't have to pass it here. You can directly read it. There are methods in Pandas that you can directly read data from SQL or directly read data from Excel, CSV, right? So what we will do, we will read data from CSV. So I will say, let's say my df is df equal to pd dot read underscore CSV, right? So if I go back to my folder, you will see I have two files, orders.csv and returns.csv, right? So what I will say, pd dot read CSV and I will pass my file name, right? So now if you see my Python script, right? and my file are in same location, so I don't have to give the path. If your file is somewhere else where your script is not, then you can give the full path, right? But this is simply you can read it. So if I just press enter, you see it has read it. Order ID, order date, ship date, everything is there, right? So this is my orders dataset. We will be working with this dataset. When we reach join, that time we will use another dataset return, and we will see how we can merge these datasets. But for now, in simplest form, we have created a tabular structure from CSV, and this is known as data frame. Right? Now this data frame is not that big. For learning purpose, it is fine. It has 50 rows. But generally, your data frame can be really big. So instead of printing full data frame, you can just say head. What head will do is, head will show you only top 5 rows, right? Or what I'll do, I'll create a new cell, because every time I'm running this cell, this command is getting executed, right? We don't have to execute this command again and again and again, right? Orders data is same. So what I'll do, I will add a new cell. Now how you will add a new cell? Either you click on plus, right? Or you click, come outside of this cell and press B. This will also add a new cell. So I will say df.head, and this time I will pass 10. So when I say 10, it will show me top 10 rows. If you don't pass anything, then by default it will show you 5 rows. If you do 10, it will show you 10 rows, right? Similarly, we have tail. So it will show you bottom 10 rows from 40 to 49. Right? We have index till 49 because index starts from 0, but total number of rows are 50. Okay, great. So this is fine. Now let's say I want to know more about this data set. So for example, I can say d types, df.dtypes. So if I run this, it will tell me what are the data types of each column, right? So for example, order ID, order date, these are the columns, right? And this is the data type. Now all the strings are represented as object in data frame. It is not string, it is object. So everything is object. Sales, quantity, profit are float and int, right? Now ideally ship date, right, and order date should be date, right? If you see the format, right, it should be date, but by default pandas will not take it as date, right? So we will see later how to convert it into date. For now we don't need it, we will see later. Apart from d types, you have some more functions, more methods. For example, df.info, right? So df.info, I think I have to wrap it in this. Yeah. So df.info will give you more info about the data frame. So it is telling that there are 50 entries from 0 to 49. These are indexes. There are total 11 columns, right? And it is also telling the each column, right, how many not null values are there. So in none of the column we have null currently, right? We will later introduce null. That time you will see less number of entries for particular column. But for now it is saying not null are 50, 50, 50, right? And this is the d type. Here again you can check the d type, right? So there are a lot of methods in pandas to explore your data frame. I'll show you a few more here. So if you go here, we have df.shape. It will give you number of rows, number of columns, right? We have df.describe. This is again an important one. So df.describe, I will just show you. So you see, it is telling some statics about the columns. Now this will only show statics of integer columns or decimal columns, because count, mean, this makes sense for numeric columns. For order ID, ship mode, it doesn't make any sense, right? So it is telling that total count of sales column is 50, quantity is 50, profit is 50. Now why it is showing 50-50? Because there is no null value. If there are null values, it will show me the reduced number of count, right? Similarly, what is the mean? So average mean of sales is 300, quantity is 3.92, right? Profit is minus 20. So this is average. Again, we have standard deviation, minimum, maximum, 25 percentile, 50 percentile, 75 percentile. So this will give you overall idea of your data set. Great. Okay, so let's move on. Now another important method is df.columns. What it does is, it will show you all the columns of your data set, right? So these are all the columns I have in my data sets. Now let's say you want to rename some column, right? So for example, let me take this, right? So these are all the columns there's as a list, right? Now let's say I want to change, let's say, customer ID to customer key, just for example, right? So what I can do, I can pass the whole list again, right? And I can change the column name here. So what it will do basically, whatever is the first column, it will assign value order ID. So column name will be order ID for the first column, right? It is in the order. So let's say if I do order date here and order ID here, right? So the first column will become order date and second will be order ID. The values will be these only, right? So basically we have matched up. So let me do that. Okay, so I have assigned new values. Now look at the DF again. So if you see, this has become order date because to the first column as index. So this is again column index 0, 1, 2. So first column is order date, second is order ID, right? And this is the customer key here, right? So if you want to rename column names, you can do like that. There is a df.rename method as well, but this is very simple, I think. Instead of df.rename, you can directly use this, pass the whole list, right? And rename wherever you want to rename. Okay, let me read it again with the proper names. Okay, great. So if I look at the DF now, this looks fine. Everything is fine. Now, generally in our data, we will have header, right? So if you look at the file, let me open the file orders.csv. You see, first line is a header name, right? Now, sometimes it might be possible that first line is not a header. You have directly data, right? So let me do that. So what I'll do, let me do Control Z, and I will say df equal to, let me copy this command, okay, and I will say df equal to pd.read csv, and I will say header equal to none. None means I don't have header in my data, right? And let me run that. So now if you see, it is assuming that there is no header, right? There is no header. So first row is a header itself, right? So we are telling there is no header. So what it is assuming, Pandas or Python, that this is also part of your data, right? By default, the first line will be the header, right? But in your data, if you think header is not there, you can say header equal to null, and it will read everything as a data. There will not be any header. It is just the index name. Once you have this, right, once the data is there, you want to give some names. You don't want to keep as it is 0, 1, 2. Then you can give the names. You can say like this, right? Now you will have, let me make it proper, order ID, order date, and customer ID, right? So now you have read the data and assigned the column names as well, order ID, order date, ship date, right? But in our case, header is there, right? So we can just remove it, right? And it is absolutely fine now, right? So if header is not there, you have to say header equal to none and then give the header column names like this. And if it is there, then it is as simple as that. Great. I hope this is clear. Let's move on to the next thing. Now, as I said you, right, you can either pass the list of columns in df.columns or you can say rename. So you can say df, your data frame name, dot rename, and pass the columns that I want to rename order ID to ID. I want to rename ship mode to shipping mode, right? So this is also you can do. Great. Let's move on to the next thing, selection of columns. Now, many times what happens, you don't want to work with all the columns, right? You want to work with few columns, let's say 2 columns, or you want to do analysis only on 3 columns, right? So what you can do, you can select particular number of columns. So what you can do, you can pass a list, right? Let me create a column list. So I will say call equal to, I'm interested in 3 columns, let's say. I'm interested in order ID, order date, and ship date. Let's say I'm interested in only these 3 columns. So in square brackets, I will say df col. Right. So I'm passing a list of columns that I'm interested in only these 3 columns. When I do that, it will show me only those columns. Right. I have to pass df col. What is the issue here? Okay. I need to have a single quotes. Okay. Yeah, now it is fine. Okay, so you pass first column name, order ID within single quotes, order date, ship date. Now you pass this list here in square brackets and it will show you only those columns, right? You can directly do this. So you can even do that. Right? But generally you create a separate list and then you pass it, but this is also fine. So I'll just comment it and I'm directly passing what columns is required. So remember there is one square bracket first and within that there is a list of columns, right? So if I just run this, it will give me these three columns, right? Now maybe what you can do, you can create df new, whatever, right? You can assign it to a new data frame. So your df data frame will be full data frame and there will be a new data frame created with three columns, right? So if I run this and if I check df underscore new, I have a new data frame. Now you can do all the analysis, filtration, aggregation, whatever you want on this, right? You don't have to select these three columns every time. Great. Now this is fine, right? But sometimes you have to, let's say, select only one column, right? So what we can do, we can just directly pass that column name like this. I don't have to pass a list I have to pass when we have to select more than one column. When we have to select only one column, we can just within a square bracket pass that column name, right? So if I just run this, you will see only one column values there. This is the index and the value of order ID, right? Now there is another way of doing it, notation. So you can say df dot order ID. This also does the same thing, right? So to select the single column, you can either pass within square brackets that column name or you can say df dot order ID. And this will also work. In tutorial, I will use this method always because this works for both single column and multiple column and I feel this more intuitive, right? Because from df, I want to select this, right? So I will use this method, but feel free to use whatever you are comfortable with. Okay, great. Now in Python, if you want to see the data type of any object, right? So for example, we have this data. This is a dictionary, right? So if I say type, let me take here. If I say type data, it will tell that this is a dictionary, right? This is a dictionary key value pair. Now similarly, I will ask what is the type of df. So it is saying it is a data frame, pandas.co.frame.data frame. Great. Now let me do one thing. I will create a new data frame with just one column. Right? I am taking just df order ID and passing it to df new. And then I will ask what is the type of df new. Let's see. So it is saying that this is a data frame. Let me run this first. Okay. Now I will again run this. Okay. Now if you see it is telling it is a series, right? If you look at df, this is pandas.core.frame.data frame, but this is a series, right? So a data frame with a single column is known as series, right? Where some more attributes of series we will learn later, but for now you have to understand that is the only difference, right? If a data frame has multiple columns, that is data frame, and if it has only one column, right? In this case, there is only one column, right? Then it will be known as series. Right? There is not much difference as such. And in general, in data engineering or data science or data analytics, we always work with multiple columns, right? In our data set, we will have multiple columns. So most of the times, 99% of the times, you will be using data frame, right? You will not be working with series, right? But you should know what is the difference between series and data frame. Okay, great. Now, let me move on to the next topic. So, we learned how to select a column or multiple columns. Okay. Now, we will learn how to select rows, right? So, this we understood. If I want to select only one column, let's say this, I can select, or I want to select order ID and chip mode, I can do. Now, what if I want to select particular rows? Let's say I want to select only row at index 0 and row at index 4, right? So these kind of things we will see how we can do it. Okay, so let's see our df again, right? Now let's say I want to only see first three, let's say first index number 0 1 2, right? So we have two functions here. One is df.ilock and one is df.lock. This is my data frame name. Let's learn about df.ilock. Ilock means index location. As per the index, I want to select particular rows, right? So again in square brackets, you have to say, let's say I want from 0 till 5. 0 till 5 means give me all the rows whose index starts from 0 till 5. But always remember in Python, when you are working with slicing of list or data frame, this last index will not come. So it will give me 0, 1, 2, 3, 4. So it will give me 0, 1, 2, 3, 4. These 5 rows it will give. So if I just press enter, you see we are saying 0, 1, 2, 3, 4. 5 it will not give, right? It will start from 0 until 4, not 5. Now you can also say from 3 till 6. So it means it will give me in rows with index 3, 4, 5. Only 3 rows, not 6. You see 3, 4, 5. Right? So if you don't give anything, you just say 3 colon. It means starting from 3, give me all the columns. You see? Sorry, all the rows. Right? So starting from 3, it is giving me all the rows. Similarly, you can say colon 4. It means start from start until let's say 11, right? Give me all the rows till 10. 11 will not be considered, right? It is not included, the last thing. So if you see from starting, it is giving me all the way till 10, right? So you can keep it empty if you don't want to give any range. Great. So this is what you can do. You can even pass the list of indexes. So I can say I want index number 2, 5, 8, right? So you have to pass a list. So these are the three indexes you want in your output. So if you do that, see, we are getting 2, 5, 8, right? So likewise, you can choose what you want. But ilog means index location. So based on index, whatever the index value is there, whatever the index is there, based on that you want to filter. Now you can also use comma and specify which columns you want. These columns are again as per the index. So first column is index 0, then 1, then 2, then 3, then 4 and so on. So we will say give me all the index from 0 till 4. So which means it will give me 0 order ID, 1, 2, 3. Till ship mode it will give me, right? 4 it will not give, remember. Right? So if I just run this, you see, we are getting 4 columns starting from 0, 1, 2, 3. Similarly, how we did for rows, we can say 5 and 10. Let's say 6 or 7. It will give me only 2 columns now, right? 5 and 6. See, region and product ID. So if you see here, 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5. 5 and 6, right? So 5 and 6 it is giving me. Right? So this is how you can slice and dice based on the index. Right? Remember this, based on the index. You cannot say give me this column because iloc will always take index for rows as well as columns. In columns also you can say give me columns 2, 4, 6 as per the index. Right? So it will give you those 3 columns: index 2, index 4, index 6. You have to just remember that index value starts from 0 for rows and columns both. Okay, so this is all about ilock. Now let's look at lock. Now lock is important. You will be most of the time using lock, right? You will not use ilock much, right? You will be using lock. Okay, so in lock, what we can do? In lock, we can pass the index value. I'll tell you what is the difference between index and index value. But basically, let's do the same thing. So I'll say 0 till 10. Okay, so I'll run this. And for now, you are seeing this is the same thing, right? But I'll tell you the difference, right? What's the difference between lock and ilock? But another thing here is you can pass the column names here, right? And that is a good thing, right? Generally, we want to select based on the column names, not like that column which is at index 4 or 5. Doesn't make much sense, not intuitive. So here I can pass list of columns if I have multiple columns. So I will say give me order ID and order date, right? And sales. Right? You have to pass in single quotes. Yeah. So this is a list, right? and you are passing to lock. Let's see what it will return. You see, it is returning me row from 0 till 10, right? 0 till 10. You see the difference now? Though it is not an index, it is an index value, right? We are not doing indexing. We are seeing all the value which are from 0, the value is 0 till value is 10, right? So if you see it, we are getting till 10. In case of iLog, we were getting 9, right? So just remember this thing. I'll show you one more example, right? So this is fine. Now we can pass the order ID, order date, and sales, right? So you can also, what you can do, you can create another DF, right? So what another DF will do, it will have all the rows from 0 till 10 and these columns, right? So you can, at the same time, you can select rows as well as columns, right? When we were using just DF notation, DF column names, that time we were able to pass the columns only. Earlier we learned how to select columns, right? But here what we are seeing is like this, right? How to select particular columns, right? But here what we are able to do, we are able to select the rows, which rows I want as per the index value, and here I can pass the columns. Okay, these columns I want, and I can assign to a new data frame, right? So this is your new data frame now. Df underscore new, and you will see this, right? So this is how you can use df.log. Now I want to tell more about df.log. So let's see. So we are saying that this is a index value, not index, right? So let me do one thing. So we have this df, right? Now in df, by default, this index is getting created 0, 1, 2 till 49. So every time you create a data frame, an index will be created by default. But what you can do, you can set df.set index, right? And you can set some other column as index. Instead of this default 0, 1, 2, you can say make order ID as an index. So your order ID column will become an index instead of 0, 1, 2, 3, 4. So if I run this, you will see order ID is an index, right? And everything else is a column, right? So order ID is an index. Okay, great. But if you look at the df again, so I will print the df again, right? So I'll say df. See, this is again a column, right? This is my by default indexes. So what happened to set index? So when I say set index, it doesn't change anything in df. It just shows that if you set order ID as index, this is how your data frame will look like. If you want to make a change, you will have to say in place equal to true. In place equal to true means in this data set itself, you want to make a change, right? You don't want to just print it. You want to make a change in this. And this argument we will use many times. In many methods, you will see if you want to make a change in the data frame, you will have to say in place equal to true, right? So let me run this. So now if you see, it is not showing anything in the output, right? Let me remove this cell, right? And if you see, there is nothing in the output, right? Because it is setting the value in the df itself. So it is not showing anything. When it doesn't set something in the df, it just shows, right? So if I look at the df again, now it has made changes in the df itself. So we have order id, order date, ship date, and so on, right? Now let's come back to df.lock, right? So what we will do now, we know that index is this now, order id. So if I say df.lock, right, now I can pass this order ID in df.lock, right? So I will say, give me rows of this particular order ID. Because this is an index, I can directly say this, right? So now if I run this, what it will give me? It will give me rows where order ID or index value is this, right? Index value is this. So if I run this, you see I am getting two rows, right? There are two rows for this particular order, right? Because there are multiple products in one order, right? Product id is different, right? So one order can have multiple rows in our data set, but this is how index is helping us, right? Now moreover, on top of it, if you want to select particular columns, you can do it. You can even pass a range. So you can say give me all the columns from order date till customer id, right? But you have to pass the name of the column. So I have to pass in single quotes, right? And now if you see, it is giving me all the columns from order date till customer ID for this particular location. Now this will not work with iLog. This is the difference, right? So if I say ilog, it will not work because ilog will still go via the index, right? So index is still 0, 1, 2, 3. So let me show you. So if you see, it is giving you error. It is saying location-based indexing can only have integer slicing, right? So we cannot pass a numeric value, sorry, alphanumeric value, right? So if I want to do ilog, I still have to pass the index, and that will work, right? 0 till 5, right? If you see, okay, here also we have to pass the index, right? So let me say 0:2. Right. So if you see, now it is working, right? Let me pass the index again here. If you are wondering that we can pass index, so let me show you. Okay. So if you see, it is not working. Right. So this will not work, or if I pass the order ID value, it will not work. So in ilog, we always have to pass the index value. Right? This won't work. This will give you error. Okay. So this is the difference between ilog and log. Ilog will always take indexes. Even if your index value is something else, it will count first row as 0, right? Second row as 1, 3, 4, 5, 6. No matter what is your index value here. This is the index value. Your index always starts from 0. This is 0, 1, 2. Similarly, column 0, 1, 2, like that. Okay, I hope you understand the difference between log and ilog, and more often than not, we will use log, right? So let me show you one more time. We can pass the column names. So if I want order ID and let's say order date, right? We'll have to pass it in a list. Remember this, right? So we'll pass it in a list, and then I can pass my no, sorry, this is my column names, right? So I'll just take it here, and here I can pass my order IDs, right? Again, I can pass multiple order IDs here. So I can say, let's say like this, and let me take few order IDs. So let me take this one. Okay, so this is my first order ID, and let me take one more. So let's take this one. Okay, so this will give me data for these two orders because my index is order ID. So it is directly filtering based on the index value, and then I want only these two columns. So if I run this, it is giving me error order ID not in index. Okay, order ID not in index. Okay, okay, we don't have an order ID column currently because it has become an index. So I will say order date and let's say ship date just to understand, right? Yeah, now it is working because order ID has become a index now. It is not a column, and here I have to pass list of columns, right? So it was not working, but now when I pass the column names, it is working perfectly fine. Okay, so this was the main thing between log and ilog. We will see more use cases of log later, but for now, I hope this is clear. Okay, great. So this we have covered, right? What we can also do, we can reset index as well. So for example, if we look at the df, right? In df, order ID is an index. Let's say I want to reset it. So I can say reset index. So if I do reset index, what it will do, it will go back to the previous thing, right? Order ID is now the column, and this is 0, 1, 2, 3. Again, it is not doing in df, right? That's why it is showing you output as well. If I want to do it in place, I can say in place equal to true. Once I do that, now my df is like original version, right? You see, this is 0, 1, 2, 3, and this is called. Okay, great. Now let's understand how sorting works, right? So what we can do, we can sort based on index or we can sort based on a column value, right? So let's say I want to sort based on index, right? So what I'll say, df dot sort index, right? If I run this, what it will do based on the index, our data is already sorted. If you see 0, 1, 2, 3, 4, still I'll go ahead and show you. So it is giving me this, right? This index was already sorted, so you are not seeing any difference. If it was not sorted, you would see the difference. Now by default, it does sorting in ascending order. If I do in descending order, so I will have to say ascending equal to false. Right? Ascending equal to false means that do sort in descending order. So if I run this now if you see the bottomest order ending with 742 is at the top, right? So index value 49 is at the top. So this row has come on the top now, right? So now if you see, you can see the sorting impact. Earlier you were not able to see it, or maybe our index is order ID, then it will sort based on order ID, right? But this is how you can sort based on the index. Again, it has done nothing in your DF, right? Every time you see the output, it means nothing has happened in your data frame. So you will have to say in place equal to true, right? If you do it, it will not show you the output, but if you look at the data frame, it is sorted in the descending order of index. Great. What I'll do, I will change it to ascending equal to true one more time and make it to the original position. Great. This is fine. Now let's sort based on the value. So for example, let's say I want to sort based on highest sales at the top. So order with the highest sales here, or row with the highest sale, I want to see on the top, and then second and third and fourth and so on. Right? So what I'll say, I will say df dot sort values, right? And I can pass column name based on which I want to sort, right? So I can say sort based on sales, for example. So I will say sort based on sales, right? So let's see, right? Again, I am not doing in place equal to true. It will just show me the output. Okay. So if you see, the lowest sale is at the top now. The row with the lowest sale is at the top, 2.5, because it is in ascending order. Everything is by default ascending, right? So 2.5, 2.3, 6.9, so on and so forth, right? And this is the highest sales, which is at the bottom because it is in ascending order. Again, if you want to do ascending false, you can say ascending equal to false, right? And you can say in place equal to true if you want to make change in the data frame. For now, I'll just show you, right? So I'll run this, and now you see the highest sales or row is at the top, right? Now what also you can do, you can also sort based on two columns. So let's say you are let's say based on quantity, I'm sorting it in the descending order. So if you see here, the highest quantity is at the top. But if you see, there are two items, 9 and 9. Right? Both rows have 9. Now you want to break the tie. Again, there are multiple rows with 777. Right? Now these values are coming in the order in which they are in data set. Right? But 7 are together. But you want to have some logic that if there is a tie, sort based on, let's say, sales, or sort based on profit, right? So for example, 7 profit is 5 here it is 15. So 15 should come first and then 5, right? So you can pass two columns. You can say quantity, and then if there is a tie, then based on profit. This is similar to order by we have in SQL. So in order by, if you give two columns, it will sort on first column first, and then if there is a tie, then on second column. Now here we have to pass two values, right? So I am saying that first should be false, which means quantity should be in descending order as well as profit should be in descending order. False, false, right? You can say that quantity in ascending, profit in descending. So you can say true, false. But for now, I want that quantity should be in descending order as well as profit. So if I run this now you will see 99 is fine, but for 77, where there is a tie, the highest profit is at the top, and then so on and so forth. Then 6, then within 6, it is sorted based on profit. Now what I will do, I will say true. True means you sort on quantity in ascending order, but then if there is a tie, profit in descending order. If you see, quantity is 2, the lowest quantity, right? All of them have 2, 2, 2, 2, 2. But within this 2, the highest profit is at the top. Why? Because profit we are saying do in descending order, right? So this is how you can sort the data based on one column and multiple columns. Again, you see the index is all over the place because we have sorted the data based on some columns, right? You want to do in data set, you can just say in place equal to true. If you do that, you will not see anything in the output. And if you look at df, here we have just like that, right? Again, if I want to reset my index, I can do. I will say df dot reset index. Now, when I do that, right, let me show you what will happen. Reset index means again reset from 0, 1, 2 in the same order, right? So if I just run this, you will see 0, 1, 2. This is my old index. The old index has become a new column and the column name is index. But this is my new index, which is starting from 0, 1, 2, 3, 4, 5. Right? So whenever you are doing reset index, what it is doing, whatever is your current index, it will make a column of it by default, right? And it will create a new index here. Now let's say you don't want this column. So you can say drop equal to true. It means whatever is the existing index, just drop it. Don't create a column out of it, right? So if I just do this, now you will see it is there. It is already sorted, right? We know because we have sorted the data. So lowest quantity row it as the top, which is fine. But we have reset the index. It is starting from 0, 1, 2 again, right? And we have dropped as well so that that index doesn't become a column. Now again, this has not happened in the df, right? So we have to say in place equal to true. Now you will not see anything in the output, but if you print df, you will see this is in sorted order of quantity and this is my index value, new index, right? So this is how these all things works together. Reset, sort, drop equal to true. Drop means drop existing index. Great. So this is how you can sort rows in a data frame. Great. So this is sorting. We have covered that as well. Great. Now let's move on to the most important topic, which is data filtration. How do you filter the data in the data frame? So let me remove this from here. I will click here somewhere and press B. Okay. So this is my data frame now. Now generally we want to filter data based on some condition, right? We don't want to just say give me index 1, index 5, index 6, right? Or even if I make order id as index, I can filter based on only order id, right? Because I can pass in df.lock, I can pass particular order id, it will give me. But what about if I want to filter based on something else? Let's say I want to filter based on reason, right? I will not always change the index. Okay, make reason as index now. Next time when I want to filter on category, let's make category as index. I don't want to do that. I want to have a mechanism that I can filter based on these column values. So for that, we can just say df.lock. Right? Now in lock, what we do? We pass all the values, all the rows that I want to see. So for example, I want to see 0 till 10. I'm passing the index values, right? And all the columns. So I will do this simply. Right? Now, instead of this 0 colon 10, you can even pass a condition, right? So let's create a condition separately. Let's call it filter condition. And I will say, I want all the data where reason equal to, so I will say df reason equal to, let's say, south. Right? So I'm saying this is my filter condition. I have to say double equal to, I think, for comparison, right? So I'm saying give me all the rows where df equal to reason equal to south. Df reason, so it will select one column, and for that column I am saying should be equal to south, and then pass this filter condition here. I'll show you internally how it works, but let me run this. So now if you see, it is giving me all the rows where reason equal to south, right? So I'm able to filter data based on a column value. Now let's dig deep how it is working. So let me run only this command. Okay. So what I'll do for now, I'll just run df just to show you how it works, right? And I'll just say df region equal to south, and I'm just trying to see what it returns. So if you see, it is returning a series, right? It has only one column. So this is a series, and it has some true false, right? Data type is boolean. Boolean is true false basically. So what it is saying, for first row with index value 0, this condition is true. So if you see here, for the first row where index is 0, reason is south, right? It means it is true. For second one, it is false because the region is not south, it is central. So wherever it is south, for that index, the values are true, right? And wherever it is not equal to south, it will be false. And this is passed in the df. So what it will do, wherever it is true, it is giving you the row. So you can imagine it like it is 1 and 0. Wherever it is 1, those rows it is giving, right? So first row it will give because the this is true. Second row it will not give, false, right? So you are saying df dot log and give me all the rows which satisfies this condition. So this is how this works. df.log, give me all the rows instead of passing the index values, right? I am saying give me all the rows where this condition satisfies, and when I run this, you see I am getting all the columns wherever this condition satisfies. So you can directly pass this condition like this, or you can create a variable which will eventually be a series, right? This returns a series of boolean values, and you can pass like that. It's up to you. Some people directly pass it, some people create a variable and pass it, right? So it is up to your comfort, right? Okay, now again I can pass particular columns, right? So for example, if I want only order id, I can choose, let's say, order date, right? So filter based on this condition, this will filter based on rows and give me only these two columns. So it is giving me all those rows and these two columns, right? So this is how your filtration works. Okay, great. Now in filter, you can give multiple condition as well, right? So for example, let me select all the columns first. Okay. Now you can say, okay, give me all the rows where region is south, and so you will have to use ampersand and give one more condition. And you can say ship mode. So you will say, let me copy this. Ship mode, or let's say profit, right, is greater than 0, right? So if you see one row is there with negative profit, right, with index 37, this row should not be there in the output because this is a and condition. And condition means this condition should satisfy. So for this condition, I am already seeing the rows, and this should also satisfy. So profit should be greater than 0. Now when I run this, it will give me error. Okay, it is giving me some error, right? Why it is giving me error? Because when you have multiple conditions, you have to wrap them in bracket. So this is one bracket and this is another bracket. So this is my first condition and this is my second condition. Now if I run this, you see I'm not getting that last row where the profit was negative. So this is my AND condition, right? You can give multiple AND conditions. You can again give one more condition, and as all the conditions should meet, right? Now, like AND, you have a OR as well. So you can use pipe operator and you say that either this condition should satisfy or this. So what it will give you, it will give you all the rows where region is south or wherever the profit is greater than 0. Right? So let me run this. Now if you see, it is giving you all the south. Even if it is negative, it will give you. So if you see, this is negative, but it is south, right? Because it is a all condition. So it is giving you all the south as well as all the profit were greater than 0, right? So if you see, we have region, other regions as well, central as well, but profit is greater than 0, that's why it is coming, right? So you can give and all using ampersand and pipe symbol. Okay, great. I hope you understood this point. Now let me go back to the normal one here, right? So this is fine, right? Now what you can also do, you can, if you don't want particular columns, you want all the columns. If you want particular columns, you can pass it here. But let's say you want all the columns. So for that, what you can do, you can directly do this, right? You don't have to do use lock. You can directly pass the condition here as well. So you can say df and pass this condition, filter condition, right? This will also work. So if you see, this is also working, right? Here also you can select particular columns, right? So this is a filter condition, right? And then you want to select particular columns. As we understood earlier, we can do this by using the list. Okay, but don't get confused. Use dot log whenever you can use. That is the best practice, right? But generally you will see this as well, right? Where people just directly pass the filter condition within the data frame. So this is the data frame. Within this, I want to filter those where df region equal to south. And this works perfectly fine. Okay, great. Let's move on to the next thing. So this is all fine. Uh, yeah, we learned that. Um, okay. Now what also we can do? We can inverse the condition using this. Right? So what I will wrap it in square brackets and I will use this tilde sign. Right? So it is just below your escape button in your keyboard. Now what it will do? It will reverse the condition. So wherever south is there, right, it will make it false, and wherever south is not there, it will make it true. So it will do reverse. Apart from south, we will see everything. Right? Apart from south, we will see everything. So it will just reverse the condition. Whatever your condition is returning, if this condition is returning true, it will make it false. If it is returning false, it will make it true. And as per that true, you will see the rows in the output that you understand. Okay, great. Now let's move on to the next topic. How do we add column? How do we update column? Or how do we delete column? Right. So let's start with the adding a new column. So now adding a new column is very easy, right? You have this data frame. You want to add a new column. You will say, let's say country you want to add. Now for that country, what value you want to keep, right? So you will say, let's say India. So what it will do, it will create a new column with the column name country at the end, right? You can always have to add at the end, right? And then it will populate India for all the rows, right? We will see other ways. For example, for some rows, I want to have India, for some US, for some Europe. We will see how to do that. But if I do it, what it will do, it will create a new column and the value will be India for that column. If you see order ID, order date, at the end we have a new column country and the value is India. Right? So this is what you can do. Now let's say you want to update a value, right? So you have new columns now. You realized okay something is wrong, right? You want to update it. So the syntax is same. Let's say I want to change it to USA. Now what will happen? It will update your country column to USA all the rows, right? So syntax is same. It means if this column exists, it will update. If it doesn't exist, then it will create a new column and assign India to it. But the syntax is same for adding a column or updating a column. Right? So if I run this, it will just create a, it will just update the value. Right? See, USA update. Right? So update and creating a column has the same syntax. If this column exists, then it will update. If it doesn't exist, it will create a new column and make it value as India or USA, whatever. Okay, great. Now you can also draw column. So for example, let's say you want to drop this column country now, right? So I'll say df dot drop, right? And I think I have to say columns equal to, and you can pass list of columns or one column. If you want to pass list, you have to give in square brackets. If you want just one column to drop, you can just pass country. So what it will do, it will drop this column, right? Again, it is showing you data in the output. It means it has not done anything in the df. You will have to say in place equal to true. Right? Now you will see df, that column is dropped, right? So we learned how to add column, update column, and how to drop a column. Now I want to update value based on some condition. So for example, I want to add a new column and say profit or loss. In case of profit flag, 1 or 0. If the profit is greater than 0, I want to call it as 1. If the profit is less than 0, I want to call it as 0, right? That is my profit flag. So my column will be df profit underscore flag. Now there are multiple ways of doing it. What I will do, I will make everything as 1 initially, right? So I will say create a new column df profit flag and make it as 1, right? Let me run this. Okay, so let's look at my data frame now. So if you see profit flag is 1. Now what I will do, wherever it is negative, I will set it as 0, right? So for that I will use lock. In lock, we can pass the filter condition as well as column. So I will say df profit, right? If it is less than 0 or less than equal to 0, whatever, right? Choose only those rows. So it will filter those rows. So if I run this, okay, I need to pass in single quotes, my bad. Okay, so it is giving me only those rows where profit is negative. Currently, profit flag is 1 for everything. Now, what I want to do, I want to say that df log, df profit less than 0, in these rows, update profit flag to 0, right? So it will filter those rows. Within that, it will take profit flag because we can choose column here in df.log and say update it to 0. So if I run this now and look at the df, you will see wherever it is negative, it has become 0. Right? So this is how you can update. Right? You can have multiple conditions as well. Right? So for example, uh, let's say you are creating a um, grouping based on how much profit you have, right? Let's say you want to do this grouping. So for example, less than 0, it should show as loss. Between 0 and 50, it should show as low profit, right? Between, or let's say greater than 50, high profit. So you have to create a new column, and it should have three values. Either it should be loss if the profit is less than 0. If it is between 0 and 50, then it should be low profit. And if it is greater than 50, high profit. So you should have a new column here, right? So what you can do, you can initialize it as loss. Everything is loss. Then you can put these two conditions one by one. One condition here, right, on the new column based on this rule, and then one more, right? And this is your assignment. So let me know in the comment section how you will do it, right? So you have to create a new column, and as per this rule, you should see the values in that new column here. Okay, great. I hope you will be able to do it. Great. Now let's move on. Okay, what we can also do is we can create a function and apply that function to each value of my column. So let me show you how. So I'll just go there. So this is my df, and I'll just drop this column. Drop columns equal to profit flag and in place equal to true, right? Done. So let's go back to df. So this is my df now. Now let's understand with a simple example. So for example, I want to get length of customer ID, let's say, or length of category. What is the length of category in this column? So I can say df dot apply, right? So I will say, so I want to create a new column, right? And I will say use category, right? So I'm saying on category column, apply this function. Now len function, what it will do, it is inbuilt function, right? So what it will do, it will apply length on each value of category. So it will take furniture and take the length and assign it or give you a value. So let me run this. So if you see, it is giving me the length of category column. Now what I can say, I can create a new column df category length, let's say, right? And equal to this. So what it is doing basically, it is creating a new column for me. How? For each row, it will take category, right? Apply this function length function and whatever it is returned. So length of furniture is 1, 2, 3, 4, 5, 6, 7, 8, 9. It is showing you 9. For technology 10. For office supplies 50. Right? So this is how you can do it. Now length is an inbuilt function, but we can create our own functions as well. Right? So what I will do, I will create a function, right? For example, this function, right? Whatever profit loss thing we did. So I'll just create this, right? So what it is doing, it is a function, name is profit loss. It is taking one argument. It is checking if it is greater than 0, then return profit, else return loss, right? Now I will apply it to my df category, right? So I'll say df category, not category. We want to check based on profit. So I'll pass profit, apply profit loss, right? So what it will do, it will for each row, right, 41.9 it will take in this function. It will check if it is greater than 0, it will return profit, otherwise it will return loss. If I run this, you see we are returning profit loss, and we can create a flag. Let's say df, let me do using dot notation, profit loss flag, profit loss just, okay. So if I run this, uh, and if I just look at df, it is pandas don't allow columns to be created via new attribute name. Okay, so let's do like this. It doesn't allow like that way, which is fine. Okay, now it is fine. Now if you see, we have a new column. See, profit loss is created, right? So you can use the supply function as well, and you can write the complex logic here as well. So for example, whatever you had the assignment, right? You can write that logic here using if else condition and return whatever is there, and then you can do it, right? Great. Okay, so now next we will see how we can apply the string functions, right? So Python has inbuilt string functions. So for example, let's say you have a string. Let's say you have name equal to Ankit, right? Let's say this is your string. This is a variable name and it has a value Ankit, right? So if I just print name, it will show me Ankit. If I do type of this, so this is a string type, right? So this is a data type string, right? So it is a string variable. Now there are a lot of functions. So for example, if I want to convert this name to upper, so I can say name dot, or let's say name dot upper, right? So what it will do, it will convert name into upper, right? Similarly, you can say lower. So it will do in lower, right? You can also check if a string starts with, let's say I want to check if this string start with A or not. Right, so it is saying true because it is starting with A. If I, let's say it starts with B, then it will say false. Similarly, we have ends with. And likewise, we have lot of string functions, right? This is false because it is not ending with B. So there are a lot of string functions. Now let's say I want to apply these string functions to one of the column of this data frame, right? Let me recreate the data frame so that we get rid of all the extra columns that we have created. So maybe I will go to the top. Yeah. So you can recreate like this. And if I come here and df again, I check. Yeah. So what I want to do, let's say I want to convert category to uppercase, right? Just for example, right? And create a new column. So what I can do, I have to say, let's remove it. I will say df, right? Category. Right. Now, if I try to use upper function directly here, just like we used for string, right? If I apply this, it is giving me error. A series object has no attribute upper, right? So this is a series attribute because when I select one column, it becomes a series, right? It becomes a series. Now it doesn't work because for series object there is no attribute upper. There is no function, right? So what we have to do, we have to convert it to a string object. So we will say dot str dot upper. Now if I do this, then it will work. Now see, Everything is in uppercase. Now I can, maybe if I want to create a new column, I can say df category underscore upper equal to this. So we will end up having a new column in the df data frame. See, category upper, right? So this is how you can use any string functions. It starts with, ends with, or whatever function are there in the for the string data type you can use here. Great. Let's move forward. So what I will do, I will just say df dot drop columns equal to category upper and in place equal to true. I'm just showing you how you have to work in real time, right? You have to sometimes create column, drop columns, and if I look at df again, now it is fine. Great. Let's move on to the next topic. So this is done. Applying string function is also done. Great. Now we will see how to work with the missing values in pandas, right? Basically, we will see how to clean data. So clean data means handling missing values, or if there are duplicates, we have to drop duplicates. So these two things we will work on now. So what we will do, I will just go back here and create some missing data, right? So maybe I will remove furniture from here, right? So from the first row I remove the furniture, and maybe from here I can remove the second class, right? From third row. Okay, so I have made two changes. In this I have made category as null, and in the second row or in the third row I have made ship mode as null, right? So I saved it. Let's read it again, right? So I'll just go on top and let me read it again, right? I will take it. Okay, this is fine. Now I will come here and see the df. We'll see how it looks like. Okay, now if you see this is none and this is also none. So a unknown value or empty value is represented as null, right? This is represented as none in pandas. In SQL it is like null, but in pandas it is NA and none. Great. Now, how do we filter null values, or how do we identify which are null values, or how we fill null values with something else? All of those things we will learn in this section. Okay. So first thing is I can check df dot is null, right? So let me run that. So I'm saying df dot is null. I'm checking if anything is null or not. Okay. What I'll do, I'll take it in the next cell just to show you how it works. Okay, so I'll just go here. Okay, so what it is returning, it is returning me a data frame of true and false, right? Wherever the value is null for each cell, right? Each column, each row, it is telling this is null, no, false, false, false. Wherever it is null, it is null, so here it is true, right? Similarly, here it is null, so it is true, right? So this will tell me whatever value is null, it will show true, everything else will be false, right? So this is one of the function df dot is null. Now, how we can use it? We can find that how many null values are there. So I will say df dot is null dot sum. We will talk about aggregate functions little bit later, but basically what it will do, each false will be considered as 0 and each true will be considered as 1. So for each column, it will sum values that okay, in order ID, how many nulls are there. So if I just run this, you see, it is telling in order ID 0, there is no null, right? But in ship mode, there is one null, right? And in category, there is one null. So this is how this is null is useful. If you want to see that how many null values are there in each column, you can see df dot is null. It will return true, false data frame, and then you can do sum. Sum basically does for every true, it will be considered as 1. For every false, it will be 0, and then it will sum it up. So this will give you a quick overview. As I said earlier, you can even do df.info. So if you do that, you will see there are 49 not null values in ship mode column, which means one of them was null. Total is 50, right? 50 entries. And 49 is not null. Similarly, category 49 is not null, right? So this is how df.info can help you in identifying which are null and which are not. Okay, great. Next is okay. Now let's say I have this null values and I want to drop, right? So what I will say, I will say df dot drop na. This is the function. What it will do, it will drop all the rows wherever any column has null value, right? So in first row, if you see null is there, right, it will check all the columns. In any of the columns, if null is there, it will drop it. So it will drop first row, basically index 0, and it will also drop index 2, right? So these two rows will be dropped. So let's see what it returns. So df dot drop na, you see 0 and 2 are not there, right? So it will check all the columns. In any of the column, if null is there, then that row it will drop as it is. Now again, it is showing you result in the output. Nothing has changed in df, right? See, df is as it is. So if you want to change it, again you have to say in place equal to true. So you can say in place equal to true, right? I'm not running it, but I hope you understand it, right? So df will have 0 and 2 will not be there in the df if I run this. Okay, great. Now we can also do subset, right? Here it is checking all the columns, but I want to drop based on particular column, right? If the nulls are there in this column, then you drop it. Now in sales column, there are no nulls. So if you see, it will not drop anything. It will give me everything as it is. So if I run this, you see 0, 1, 2. These rows are there, right? Because sales is not null. And I'm checking only in sales, right? Now let's say I say category. Right. Now it will check only in category column. If null is there, then it will drop that row, which means this row will be dropped, right? But this row will not be dropped because this is in ship mode null. Category is not null for this. So if I just check it now, you see 0 is gone, but 2 is still there. I can give multiple column. Let's say I will say that check in category and ship mode. By the way, when you pass column names, you can pass in single quotes or double quotes. Both works, right? In Python, even if you define a string, you can give in double quotes or single quotes. Both works in Python. So now both the rows will go. See, 0 is also gone, 2 is also gone. Right? So this is how you can drop null values. Now, if you want to fill null values, you can do this. df dot fill any. Right? Let me show here. I have not done in place equal to true, right? So my data set is as it is. So now I will say df.fillNA unknown. So let me remove this in place equal to true for now. Right? And if I run this, you will see that wherever null is there, it has populated with unknown. Right? Now if you want to do in place, you can say in place equal to true. Then it will make change as it is in the data frame. Right? So you won't see anything in the output as we know. And if you do df, you see it has unknown and unknown. Right? So this is how you can handle it. Great. Again, if you want to fill NA for a specific column, you can say df category dot fill NA, and that's it, right? So you choose that particular column. Here we are saying full data frame, but if you want particular column, you can say okay, in category column fill NA, right? And in with unknown string, you can give any string. We have given unknown here, and in place equal to true, right? If you want to fill with the mean value, right, you can say df says dot fill and df says dot mean. So what it will do, it will get the average of this column and fill that wherever there is a null value, right? Great, you can explore this. I'm not explaining this is fill forward, fill backward. You can google about it. Great. Great. Let's move on to the drop duplicates. Okay. Now, what is duplicate? Duplicate means you have exact duplicate value in your data frame, right? So let's understand with a simple example. So maybe what I will do, I will take a simple example to explain this concept, right? So let's take this example. Okay. Let's go there. Okay. So you have this data, right? Now in this data, there are no duplicates as such. Everything is different. So let me create some duplicate. So let me say age is 30. Okay. Now if you see age is 30 here and age is 30 here, right? Let me create one more as it is same. So I'll say Ankit one more time, and this is 30 again, and this is 35,000 one more time. Okay. Okay. Now if you look at the data, these two rows are exact duplicate, right? See, Ankit 30, 35,000. Ankit 30, 35,000. Right? So these two rows are exact duplicate. And if you look at this, these three, based on age, they are duplicate. I mean, we want a duplicate, but I'm just saying, based on age, these three are same. Great. Now what I want to do, I want to drop duplicates. So what I'll say, df dot drop underscore duplicates. Right? Let me check. Drop duplicates. Okay. Let me copy this. Df dot drop duplicates, and that's it. And then we will see what will happen. Okay. So now if you see what it is doing, it is checking on all the rows if there is exact duplicate. Right? So these two rows are exact duplicate. Right? So what it is doing, it is keeping only the first row and dropping this. Right? It is keeping only the first row and dropping this. Now, why it is dropping this row? Why it is not dropping this, right? If you see index 3 is dropped, you will ask why not index, it has dropped index 2. So by default, it will drop last value. If I want to change the behavior, I can say keep equal to last. Now what will happen? It will keep the last value. By default, it is keeping the first value, right? So I'm saying keep the last value. Okay, last I need to pass in codes, I think. Yeah, it has to be small case and like this. Okay. Now if you see 2 is 2 is dropped, right? So I am saying drop duplicates, and wherever there is a duplicate, keep the last value only. Right? By default, it keeps the first value. So if I say first, this is my default behavior. Right? So if I run this, you see it is keeping the first value wherever duplicates are there. Right? If they are, let's say, one more row, right? So it will drop all of that. So for example, let's say I have one more Ankit, and one more 30, and one more 35,000. Right? So if I see now, you see these three are exact duplicates. Now what will happen? It will keep 0, 1, 2 only. If I say last, it will drop 2 and 3 and will keep 4. See, 0, 1 and 4. Right? So this is how you can drop duplicates. Now in many cases, in fact in most of the cases, you want to check duplicates based on particular columns. So let's say I want to drop duplicate based on name column only, or let's say based on age column. Now based on age column, all these four are duplicates. So it will keep only one value. So I will say subset equal to age. Basically, let me remove this for now. Basically, I am saying just check based on age, right, and drop the duplicates, right? This is how it is. Subset equal to this, right? Let me run this now. Now, if you see, it is keeping only the two rows. Why? Because all four are duplicates based on age, right? Again, you can pass keep equal to last, then it will keep the last value. So you can decide you want to keep the first or last. Right? In this case, it makes sense what you want because other columns can be different. Right? Here, Ankit 35,000. If we keep first, it will be Rahul 30,000. Right? So it depends what is your requirement. Right? So first and last gives me different results when I am using subset. In case of full duplicates, it doesn't matter, right? Because full row is same. But in this case, full row is not same. Subset is age, but you want to keep either the Rahul or Ankit, right? So it depends on what you want. Okay, great. So this is about how you can drop duplicates. You can even give two columns. So you can say drop duplicates based on age and let's say age and let's say salary if I say. Right. Now, based on this, just think about it, right? Now, this is not a duplicate anymore, right? 30,000. There is no other 30,000. But these three are duplicates, right? So we will have Sumit, Rahul, and one of the Ankit. You see, Sumit, Rahul, and one of the Ankit. Because we are checking duplicates based on combination of these two columns. And 30,000 is unique, right? There is no one more duplicate based on these two columns. Great. Again, it is not done in the data frame, right? So you have to say in place equal to true. In place equal to true. If I run this, and again it is not showing anything, which means it has done changes within the data frame. So we have only three rows. Great. Let's move on. Okay, now we will discuss how to work with date and times in pandas. Great. Let me go back and let me create our original data frame quickly. This is my original data frame. Okay. So now, if you remember, I will show you quickly df, right? This is my order date and ship date. If I check df dot d types, data types, right? It is telling that order date is object and ship date is also object, right? So it is consider them as a string, not the date. Now, if I want to convert it, what I have to do? I have to say pd dot to date time, right? Or let me show you the data first. So let me cut it. Okay. I'll take a new cell because I want to show you something interesting. Okay. So I will say pt dot to date time, right? I'm saying convert it into date time. What? What? This df order date. So this column I want to convert it to date time. And let's see if it will work or not. So I will run this and it is giving me some error. Let's see. So it is saying time data doesn't match the format MDY. So now what is happening? By default, it checks that data should be in YYY MMDD format, right? If your data is not in YYY MMDD format, then you have to tell in which format your data is, right? So you will say format equal to percentage Y hyphen percentage, no, not Y. So in our case, it is percentage D, right? Percentage D, right? Hyphen percentage M month, right? Hyphen percentage Y, right? Yeah, this is how it is. So what I'm saying, my date, order date is in this format. If it was in YYYMMDD, it would have worked automatically. But here it is not the case. So if I run this, now it is proper. Right now it is proper. So what I will say, make df order date like this. So I will assign this new derived date time format to my order date column. Now this is done, and if I look at the data now, it looks similar, but this is now in YYMMDD format proper, right? And if I set d types, you see it is showing me date time, right? Similarly, we will do it for ship date, right? So I will say ship date. This also is DDMM so we can use as it is, right? Done. And now let's look at df dot date types. You see both the columns are date time, right? Now we can do date time operations, anything that we want to do. Okay, so now let's say I want year, right? So I will say df order date dot dt. I need to create a date object of it dot year, right? So it will extract year from the ship date or order date, sorry, order date, right? So if I run this, no, I don't have to use function. So see, it is giving me year. So maybe I can create a new column df, let's call it order underscore year, right? So it will create a new column where we have order year. See, right? Similarly, if I want month, I can just say df dt dot month. So it will give me month. This is for November, June, right? So I can get any attribute of a date now. For example, I can get day, date, name, month, year, and all the attributes. Now I can also do date kind of filter, right? For example, if I want all the orders whose date is greater than this, now it will work. Earlier it was a string format, so this filters will not work properly, right? Now I have changed it to proper date format. Now I can say give me all the orders which are greater than 1/1/2023, right? So all the orders this 2020 will not come, right? Let me run this. uh, Okay, so there is no data. There is no data where orders are greater than 2023. Let me make it 2022. It is not there. 21, yeah. So I'm getting only the orders which are greater than 2021. Right? I can just say this. Right? So this is how now date filters will work because we have converted this order date to proper date time data type. Great. So this is how you will work. Now there is one more interesting thing that how you can even sort based on this now. It will be sorting and everything will happen properly now. You can also find days between two dates, right? So let me show you. So what we want to find, we want to see how many days it is taking from ship date to order date, right? So I'm saying df ship date minus df order date. From this subtraction, give me days. So dot dt dot days. So it will tell me how many days it is taking from ship date to order date. Sorry, from order date to ship date, right? So you ordered today and shipped maybe day after tomorrow, so it will give me 2, right? So if I just look at df, see transit days is 3, right? So if you see order date is 8, ship date is 11, right? So it is 3. Similarly, if you look at here 16, 12. So this is giving me 4. So this is how you can do it. Great. Awesome. So we have covered a lot of things so far. Right now we will cover two most important concept. One is aggregation and next is joins. Okay, great. So let's move on to aggregation. Aggregation is same like group by we do in SQL, right? And the filter that we did earlier, right? That is just like where clause we do, right? We gave filter conditions. If you remember, if I go up, all this conditional filtering is like where clause we give. It goes row by row and filter the data. Right? So this is all where clause. In where clause you give multiple condition. Similarly here you are giving, right? Now we will discuss about how to do group by, basically how to do aggregation, right? Now if you want to do an entire table aggregation like sum of sales, so simply you can say df sales, right, and dot sum. So it will give you overall sales. So this is the total sales. If you want minimum, it will give you minimum. Simple, just like in SQL you do min, max, mean, everything you can do, right? This is fine. You can get count, and this is actually interesting. So this will give you how many unique values are there, right? So there are 4 unique values in region column, right? So we have south, east, central, west. So it is telling you 4 distinct values are there, right? You can even get which are those distinct values. So for example, if I run this, it will give me all the unique values in category column. So we have null, we inserted one null, right? Furniture, office supplies, and technology, right? If you look at df, we have a null. I read the data again, right? See, so we have one null furniture. So these are the distinct values. So when you do select distinct category from your orders table, this is same thing, df category dot unique. Great. So you understand how aggregation we are doing. But generally we want to do aggregation based on some column, right? We want to use group by kind of thing. What does that mean? That means that let's say I want category wise total sales. So when I do this df sales dot sum, it is giving me entire sales, right? What is the total sales I have done? But what I want to see, okay, in furniture category how much sales is done, or maybe region, in west region how much sales we done, in south how much sales we have done. So for that we will use group by. So I will say df dot group by, right? And now we have to pass that on which column I want to do group by, right? So I will say I want to do group by on, let's say, region. right? So I want to do group by on reason, and then I want sum of sales. So I will say group by reasons and take sales and give me sum. Okay? So this is how the syntax is. Df dot group by category, and then from the group take sales and give me sum of sales. Right? So this is how this works. So if you see, it is telling in central region this is the sales, in east region this is the sales, south region this is the sales, in west region this is the sales. Right? So I will just repeat the syntax one more time. You have to say dot group by. Again, you can pass multiple values. You want to group on two columns, so you have to pass a list. Right? Sales. So group on this and give me sum of sales. Right? Group on region, and within each group take sales column and give me sum. Right? So there will be four groups. Right? One for central, east, south, west. So for each group take sales column and give me sum. Right? So this is how you have to remember. Now, many times you don't want just one value, right? You want sum as well, max as well, min as well. So this is the syntax for that. So you can do this. So I'll just take this, right? We are doing on reason, let's say, right? What I'm saying, that group on reason from each group means one group is central, another is east. Take sales, aggregate it, and give me min and max both. Here I am directly saying sum, right? But if I want min, max, and let's say sum as well, right? So I'm saying aggregate and give me all these aggregations, min, max, sum for each region, right? So it is giving me for each region, this is the minimum sales, it is the maximum sales, it is the sum of sales, right? So this is how you can do it. Now there is another version of it. If you see, let me show you. Now here, if you see, these column names that are coming are not proper. It is coming as min, max, sum. What I want to do, I want to give proper column names, right? So what I can do, I can say, not like this. Wait. Okay, I'll cover it later. But now what I want to do in this, that I want to, let's say, do sum of sales and sum of profit. Here if you see, we were choosing only one column, sales, and we were getting min, max, sum of all of that. But what I want now, I'm saying that group by on category, but give me sum of sales and sum of profit, right? So I'm not telling which column here. In aggregate itself, I'm passing a dictionary, and in this dictionary, I'm saying the column name, sales, and what kind of aggregation I want, profit, and what kind of aggregation I want. Right. So if I run this, you see it is giving me sum of sales and it is giving me sum of profit. Right. Let's say I want mean of profit. Right. So it will give me sum of sales and mean of profit. See, this is the mean of profit. Right. And this is sum of sales. Okay, so this is the most used one because generally in SQL also we can do simply sum of sales, average of profit, minimum of profit. So this is very generalized, right? You can pass the column name and what aggregation you want. You can pass the column name and which aggregation you want. Okay, great, great. Uh, this is fine. There is another function, right? Just to get the value count. So for example, if you want in category, right, in each category, how many rows are there, right? So this is kind of getting a count, right? So you can simply say count here. Right? So it will give you count, right? So 11 records of furniture, 28 of office supplies, and 10 of technology. Similarly, you can do it here as well. If you directly want, this is a shortcut to get the count. You can just say df category dot value count. So it will give you office supplies, there are 28 rows, in furniture 11 rows, and in technology 10 rows. Okay, great. In this, there is one more way. I don't remember where you can give the column name as well. That if you take minimum, what column name should be there in the output. So you can pass that as well. You can check the syntax. Okay, great. So this is all about aggregation, right? I hope it is clear. So you can group on multiple columns as well as I said, and then you can get the aggregated value. Great. Okay. Now there is one more interesting one. You can create a pivot table, right? So let me show you quickly. So there is a method called pd.pivot table, right? I want to create a pivot table on df on my data frame. So you pass the data frame. Now you are saying that index should be reason, column should be category, value should be sales, aggregate function sum, and fill value 0. So let me run this and then I will show you what it does. So what it is doing, that whatever you give it index, it becomes your rows. So it is central region, east region, south region, west region. Whatever you give in columns will become your columns, right? And here it is giving you this aggregate sum of sales. So what it is doing, it is telling for central region furniture category, this is the total sales. Central office supplies category, this is the sales. It is kind of pivot table you are creating. If you have worked in Excel, in a similar way you create a pivot table. You have something in rows, something in columns, and some aggregation. This fill value is optional. So if you don't give it, if let's say for south region and technology nothing is there, right, there is no sales, right, there is no row basically south and technology, so it will give you null by default, right? But if you want that instead of null, it should give default value as 0, so fill value will be 0, you can put, so it will give you 0 instead of null. Okay, so this is also very handy if you want to do some kind of quick aggregation and do the analysis. You can use pivot table. Very nice, it is, you can use. Okay, let's move on to the next important topic, joining, right? So what we will do, we will create one more data frame now. So let me do one thing. I will just make it proper. So I will make it furniture and make it second class and save it. Now let's go back and take this. Okay. So now what I will do, I will create a data frame with this name, df underscore orders, right? And we have one more data frame. I'll just show you returns, where we have returns, right? So returns. Okay. So this is your orders data set. This is your returns data set. And let me run this. Perfect. So df orders we know. Let's look at df returns. So DF returns is telling me out of all the orders which we have in DF orders, which order were returned. So some of the orders, let's say, were returned by customer. So you have order ID that these orders were returned, as well as the return reason why they were returned. So bad quality, wrong item, other, whatever. Right? Now, what I want to do, I want to join these two data sets, right? So, for example, the kind of analysis I can do is okay, because of bad quality, how much sales we lost. Now, sales is not there in this data set, right? But order ID is there. So, we can merge these two data set or join. In SQL terms, you can say join, but in Pandas we call merge, right? Because the method name is merge. Right? We can merge it based on order ID, and we will have a final data set where we have return reason along with all the columns of orders, right? So let's see how it will work. So I will say df equal to pd dot merge. Okay. So I'm telling that I need to merge. So this is the method merge. Now I need to tell the left table or left data frame. So left data frame for me it is df orders. Right. Next is right, which is your right data frame. So that is df returns. Okay. Now, so this is your left and right table kind of. So this is my left data frame, right data frame. Next, I want to tell that what kind of join you want to do. So I am saying I want to do inner join. Right? Inner join means only the common records will come. It means only the orders which were returned, only those will be present in the output. So we will see. Okay. Next is on which column I want to do. Right? We have to tell on which column I want to join these two data frame. So obviously we know it is based on order ID, right? So order ID is there in both, and I want to join based on that, right? So what it will do now, it will join the data frame inner join based on order ID. right? So it doesn't matter. You can pass this before as well. So let me put here. And because we are giving the argument name as well, so order doesn't matter. So how inner on order. Great. So now let's look at the DF, how it looks like. Okay, awesome. So if you see, we have only the returned order, right? If you see, there are 8 rows. Here there are 11 rows because one of the order can have multiple rows here, right? For example, if you look at this, 36 is there 3 times, right? But it is a returned order, so all 3 rows from orders data is coming. Right now we have the return reason as well. Now I can do simply the aggregation. So if I want to, let's say, check for each return reason how much sales is gone. So I can say df dot group by, right? Group by on return reason, right? From each group take sales and give me sum, right? So they are telling that because of bad quality, we lost this much sales, because of other return reason this much, and because of wrong item this much, right? So basically, this is how you can do merge. Now let's say I want to do left join, right? Inner join means only the return data is coming. Basically, whatever orders are there in returns are coming because inner gives the common. So I'll say left. What left will do, it will give all the data from left table. In our case, DF order is left table and the matching data from right table, right? So if I run this and if I look at the DF again, or if I run it again, so it will also show me DF. It will also show me bad quality, other wrong item. This is fine. Group by return reason. Let's look at the DF first, right? So let's look at the DF. It should give me one null as well, not sure. Okay, so none is there, right? But it is not showing none when I'm doing a group by, right? So if you see, all the records are coming, all 50 records. And wherever there is a return, we are getting the return reason and everything else is null. Null or none, right? But I was just wondering when I do group by on this now, right? It is not showing me the none records. So maybe I have to do null handling first. I need to populate something and then do group. Okay, fine. But you understand how this left join is working. Similarly, you can do right join, you can do outer join, you can do cross join. When you do cross join, you don't have to pass the column on which you have to join. Because cross join means each row of first table will join with each row of second table. I can show you. So I'll say cross, right? So how many rows will be there? So in orders data set, we have 50 rows and in return we have 8. So 50 into 8, it means 400 rows should be there, right? So let's see. Let's look at DF. If you see, 400 rows are there from 0 till 399, right? For because each row of orders data set is joined with each row of returns, right? And that's why there is no on, because there is no column on which we want to join. It is just a cross join, right? I'll just go back and make it left join for now. Okay, so now we should have 50 rows. Yeah, perfect. Now there is one catch here, right? If you see, I am saying join on order ID. Now, what will happen if I, let's say, go here, open this? Now, it might be possible, let's say in this, the column name is return order ID, right? Now, let me try to run this. So I will read these two again, right? If you look at the DF returns, the column name is return order ID. But in DF orders, it is order ID, right? Now, what will happen when I do a join? Let's see. So I'm running the same and I'm saying on order ID. Now it is giving me error. It is saying key error order ID. So what it is doing, it is trying to locate order ID column in both the data frames, right? It is there in DF orders, but not here. So in this case, what you have to say that from left, use order ID column and right on use return order ID column. Right? That way, it will work fine. Right? So if I run now, there is no error. If you look at the data, now it is coming proper. Right? And you have this column as well, return order ID now. Earlier, that order ID was not coming because it was a column, a common name, right? But now, because it is a different name, it is coming, right? So wherever return is not there, both columns will be null. Wherever it is there, it will be there. If you want to drop this column, now you can drop it. It is of no use, right? But yeah, this is how it works. Okay, great. So this is your joining or merging. Now next, let's understand union. Right? Uh, we do union in SQL. Right? So you have, let's say, two data sets. So let me take these two data sets. Okay. So we have these two data sets. Let me run this, and this is my df1. Right? So this is my small data set df1, and this is df2. So I just quickly created. Now, what I want to do, I want to union them. Union means I want to combine them, this data set and this data set. So, final data set will have 6 rows, right? It is not a join that I want to join based on ID. No, I want to append this data set, append this, right? So, for that, we can use concat, right? So, you can just say, give me a new data frame. pd.concat is the method, right? So we had here pd.merge for merging. For this, we have to have pd.concat, and we can pass all the data frames that we want to concat, right? So df1 is this one and df2 is this one. And if I just run this and look at df, it is giving me the new row, new data frame with 6 columns. Now I can again do reset index, right? Because index is like 012 and 012. So it is taking index as it is from these two data frames. So what I can do, or I can say this as well, ignore index equal to true. Right? So if I just go there and I will say ignore index equal to true. So if it will ignore index of these data frames and create its own index, right? So if I run this now, not reset df, just okay, there are two commas. So now if you see, it ignored these indexes and created its own, right? So id names. Okay, great. Awesome. So now what we will do, we will see. So these are the main operations that you will have to do whenever you are working with Pandas data frame, right? Now we will learn how to write data back, and then after that we will see how to work with databases. Okay. So what we will do, so we have this df, let's say, right? Now what I want to do, I want to write it back to a file. So whatever data frame you have, right? So let's say you created this final data frame. Let me work on this one. So let's take this, and then I will say df dot pd dot merge. And now if I look at df, this is my data now, right? What I want to do, I want to write back to a file. So instead of read csv, you can just say to csv, right? And I will say full orders dot csv. So what it will do, it will write this data into a file. Now there is one important thing. Let me run this. Now I will go to my folder. If you see, this file is created, full orders dot csv, right? And if you see, it has all the data. But one thing is that there is one index column as well. So it has it in the index column as well, which is generally we don't want, right? There is no column name. It is empty and 0, 1, 2, 3. Generally, you don't want that column. So what you will do, you will go here and say index equal to false, which means don't write the index, just the columns. Now let me go back and open it again. Now if you see, now this is proper, right? We have order ID, and there is no index as such, right? Great. Now similar to, let me close this. You can even write to Excel file. So you can say Excel LX, Excel SX. Okay. So this is the extension of Excel file, right? So if I just, so you have to say dot to Excel, right? So it will write to in a Excel format or Excel file. So if I go here, you see this Excel is created, and you can Okay, I need to go to folder, I think. So let me open documents, pandas tutorial, and this is my Excel file. If you see, this Excel file is getting created automatically, right? So it is the return order ID and return reason. So for whatever there is no return, it is as empty. It is not writing it as null in Excel. It is writing it as empty, or even in CSV. Right? It is with proper formatting as well. If you see, order ID and these columns are in highlighted bold. Okay, great. You can even write in JSON. So for that we have two JSON and kind of thing, right? Great. Okay, now what we will do in next step, we will work with the database, right? How you read data from database, how you write data to a database, right? So we will use MySQL. If you want, you can use SQL Server or anything. Little bit connection string changes will be there, even for Postgres, and some libraries will be little different, but mostly it will be same, right? So I will use MySQL for that. Okay. Okay, so like we have written data to Excel, we can even read data from Excel. So for CSV reading, we need the read.csv method, right? To read the Excel file, we have to say, let's say df equal to, or let's say df underscore Excel equal to pd dot read underscore csv, right? And then I will say this Excel file, right? So I will read this Excel file, okay? And let's run this. Okay, so it is saying there is some error, invalid start byte. Okay, okay, sorry, it has to be read Excel, my bad. Okay, great. Now, if you look at the data, df underscore Excel, we have the data. We have just read the data, right? It has, you see, return order ID and return reason. Okay, great. Now, what we can also do, Excel can have multiple sheets, right? So let me go to the Excel once again. Documents, pandas tutorial, and this is my Excel, right? Let me create one more sheet, right? So I will call it as, let's say, orders one, right? And let's create one more sheet, orders two, and in this I will just keep 2 3 rows just to show you how we can read multiple sheets, right? So let me take this much, yeah. Okay, so I've created one more sheet, right? Now I can read either this sheet or this sheet, right? Based on whatever I want to read. So I will go here and say, right, file name is same. Now I will say sheet name equal to orders 2. So this is my sheet name, right? So whatever sheet name I give, that sheet name data will be read from the Excel. So if I run this, and if you do df Excel, I have only 3 rows, right? If I want to read sheet 1, you can just read sheet 1 and you will have full data. Right? So this is how you can specify the sheet as well, right? Similarly, we can read from JSON or many data sources we can read, right? We can even read from Parquet file. For that, we have read underscore Parquet, right? So if you have Parquet file, you can just do this, and we will be able to read, right? Okay, great. Now what we will do next is we will learn how to read and write data from a database, right? Because many of the times as a data analyst or data engineer or data science, you will be reading data from database and doing all the transformation or data analysis in Pandas, right? So for that, what we will do, right? We will read data from MySQL, right? Now, Pandas supports almost all the databases, MySQL, Postgres, SQL Server, right? So you can try with whatever database you have. I will show you with MySQL, and I will also tell you what kind of changes will be there if you use some other database, right? So we will learn how to read data from MySQL. Great. So let me go back to the notes, right? And we need some library. So I'll show you which all library you need, right? So you can say, you can directly install from here as well, just exclamatory mark and this. So this will install MySQL connector for Python, SQL Alchemy, Pandas is already there, and PyMySQL. So we need all of this. You can just install this, right? Great. Now next, we will import. So let me take this and show you how it works. Okay, so from SQL Alchemy, I'm importing create engine. So this create engine is basically a engine, right? It's a connection between Python and your MySQL database. So using this create engine method, we will create that connection, right? What is this text? I will tell you. But from SQL Alchemy, I'm importing create engine method. And then this is already imported, which is fine. Let me remove everything else, and this is my connection string. So I'm saying my engine equal to create engine, and this driver I'm using MySQL plus PyMySQL. This is my username. So my MySQL username is root, and my password is this MySQL123. This is my host. You can check this host in your MySQL installation, and this is my port, right? And this is the database I want to connect to. So by default, database is sys. If you want to connect to some other database, you can give that name, like whatever database you create. Okay, so this is how you have to pass username, password, host. This is my local host, port, and this is my database in my SQL, right? So this will create the connection string. So I'll just run this, right? And this is done. Now what we will do, we will read data. So it is simple. We can just write a query and read data. So I will show you this. So query equal to select star from employee. So let me check in my database if employee table is there or not. Okay, some orders table is there. So let's read from orders table. Okay, so select star from orders, right? So this is my query basically, right? And I'm saying df equal to create a data frame using pd.read SQL, right? It is very similar, like where pd.read Excel, read CSV, similarly read SQL. Here we have to pass two parameters. One is query, right? Using which query I want to read data. And then this connection parameter, because this will be used for authentication and reach out to the server, that I want to reach to this server, and this is the username and password, right? So once I do that, it will run and it will create a data frame, right? So once this data frame is created, you can do all the operations that we have done, right? Now there is no difference, right? The way I read data from Excel, CSV or database may be different, but once the data is there in Pandas, you can do all of the operations that we were doing. And in this query, you can write anything. For example, you can say where, let's say order underscore ID is greater than 10, right? So it will run this query, right? Whatever query you are giving, and result of this query will be there in df. So if I just run it again and see the df, you see order id starting from 11, right? Because I have said order id greater than 10. So you can give any query, any complex query. You can give aggregation, window function, whatever you want to give, right? The result of that will go into this data frame. Okay, great. Great. Let's move on. Now, what we want to do, you can even do joins and all. So you can have multiple tables, write a query with inner join, left join, or whatever, right? And bring that data and do it. Great. Now let's move on. The next thing is how to write data, right? So let me show you how do we write the data. Okay. So you have to use df.toSQL. So we had two CSV, two Excel, two Parquet, similarly two SQL. Now here we have to give the name of the table, that in which table I want to write the data, right? So let me create a table orders underscore copy, right? Let me read full data. Okay, it is fine. We have whatever rows we have. I want to now once the data is in df, right? Or maybe let me read it from CSV, right? Let's do this. So I'll just read this, right? So I have full data in df now, right? I'll show you quickly. Df, not here. Okay, so let's go there. B. So I have all 50 rows, right? Now I want to read this, write this data into SQL, right? So I will say df.toSQL. I'll create a new table orders copy, right? Again, I have to give the connection. So my connection is this engine basically. So this is a con parameter. In this, I need to pass this engine information, right? index. Do you want to write index also in your table? No, I don't want to create index, right? So this index will not be created in your table. If exists replace. If exists replace means if there is a table already existing in your database with name orders copy, then what it will do, it will drop the table and create the table again, right? If it is not there, then obviously it will just create it, right? So I will just run this statement, right? It is 263. Now it is 266, right? So basically it is telling how many rows it has written to the database. 50 rows, because we had 50 rows here, right? Now let me go back and see what is there in this. So this is my SQL. Let me run this. So if you see, we have the 50 rows written here, right? All the data is here. Perfect. So this is how you can write data. Perfect. Now, if you see, we have used if exists equal to replace, right? Now we can also say append. Append means what will happen if table is there, it will append the data, right? If table is already there, it will append the data, which means if I run it again now, right? What it will do, it will add 50 more rows, right? Because 50 rows are already there, and this time I am saying append, so it will add 50 more rows. So there will be 100 rows. Let me show you the count. So we have 50 rows, and let me run this. Done. And again, if I run now, see 100 rows, right? So you have data will be appended, right? So if you want to append the data, use this parameter as append if exist. If you want to create the table, new table every time, you can just there replace, right? So in replace, it will drop and do again. Great. Now many times what we want to do, we want to do this. We want to truncate table and insert data. Sorry. Right? Because every time I don't want to drop table. When I say replace, it is not truncating data, it is dropping the table itself. Every time this table will be dropped and created again. But I don't want that. What I want to truncate data and then use append to insert data. Right? That way I don't have to create table again and again and again. Because if you create the table again, all the permissions will be gone. Let's say you have given some permissions to some users or whatever, right? Then those permissions will be gone if you every time drop and create the table. So you don't want to do that. You just want to truncate table, keep the table structure as it is, just delete the data and then load. It is a full load, but not creating table again and again. So for that, we will have to truncate the table, delete the data, and then use append, right? So that our all the data will be new every time. Great. So how do we do that? For that, what we have to do, right? Okay. By the way, we have three parameters. We have a fail as well. So we have replace. It will drop and recreate table. Append, add rows to existing table, and fail will error if table exists. So if there is already a table and you try to load the data, this command will fail. Okay, great. Now we want to execute some statement, right? So for that we will have to use this. So let me take it here, right? I can write my query in the text wrapper, right? What happens, it creates a text object, right? You can not directly use this query in the execute statement. I will just show you. You will have to use this text wrapper, right? We imported from SQL Alchemy, pass it here, then it will create a text object, and then you can pass it into the next step, and in the next step you can just do this. So if you want to run any update statement, delete statement, any kind of statement, you can use this, right? And same approach we will use to truncate data. So what I will say truncate table, right? And my table name. So my table name is this. So I want to run this statement, right? So I will say with engine. So this is my engine dot begin as connection dot execute query, and then I will commit it, right? So this is how you have to write your any statement. We can delete a statement, update a statement, any kind of SQL statement. If you want to run, you can do it, right? So there are three things. One is you want to read data, then you will use read SQL, simple, right? If you want to write data of a table directly from a data frame data you want to write, you will use df.toSQL, right? If you want to run some other statement like update, delete, any kind of statement, merge statement, then you will have to use this method, right? So you can write your query here and then execute it like this. So let me run this. This is done. Let me show you the data now. So it should be empty now, right? You see, it is truncated. Now I can again run my this with append, right? It means we have deleted the data and inserted again, right? So now again we will have 50 rows, right? Great. So this is how you will work with database. Now when you work with, let's say, some other database, let's say SQL Server or Postgres or anything else, right? You just have to change this connection string a bit. That's it, right? Apart from that, there is no other changes required. Everything else, read SQL to SQL or this update statement, will work as it is, right? So for example, if you are connecting to SQL Server, right? So this, instead of MySQL, you will have to use SQL Server. I will just show you quickly. So here, if you see, we are using MS SQL plus PyODBC. We will pass server name, database name, ODBC driver, right? Apart from that, apart from this create engine script or create engine object, right? Everything else will be same. There is no change, right? No matter which database. Again, if it is Postgres, you will have to use some Postgres driver instead of MS SQL or MySQL, right? But otherwise it is all same. Okay, great. Now last thing is we will work on the project. Okay, now the last section is we will do a end-to-end project. In this project, we will read a JSON data, right, and create tables in MySQL, right. So I'll show you the architecture of the project. So let me go here, and so this is what we are going to do. So I'll just show you. We have the orders data in JSON format. I'll just show you the data. We will read this data and flatten this data in Pandas, right? And once we flatten it, we will create product table, customer table, and orders table in the MySQL, right? Once this data in available in MySQL, we can query this data using SQL, right? So we will learn a lot of things, many things that we have learned during this tutorial. All of that we will apply, and we will also learn few more things like how to read JSON data, how to how to flatten data in Pandas, right? So it is going to be very interesting project. Okay, great. So before I go there, let me show you the JSON file. So this is my JSON file, right? And this is my orders data in a JSON format. So let me show you how it is. So this is a list of JSON, right? This is a list, right? If you see, this is starting with square brackets or list or array, whatever you call it. And this is first element of list from here till here, right? And this is a JSON. So if you see, this is a JSON which has all the order details of one particular order. So for order ID 1, this is the order date, this is the total amount, this is the customer who bought this, who placed this order. Then we have products. Now products is further one array. Why? Because in one order there can be multiple products bought by a customer, right? And then that's it, right? Similarly, then order ID 2 is starting, right? And then order date, total amount, and so on and so forth. And then we have around 13 orders, 12 orders, right? Great. So what we have to do, we have to read this data and somehow convert it into a proper tabular format for product table, customer table, and orders table, and load it into MySQL. Right? We will have to do lot of things. We have to drop duplicates because see, one product, let's say P01, can be bought in multiple orders. So we don't want to insert this product multiple times in my product table, right? P01 should be only once, right? So we will have to see how we can work on it. Great. So let's start with reading this JSON file first. So what we will do, we will say, we will import JSON first. Import JSON, right? And we will say, we will create a file object and say open orders underscore etl dot json, right? This will create a file object, right? I have to pass in single quotes or double quotes, right? Now I will say data equal to json dot loads and pass this file object, right? Let's see what will happen. So this is done. JSON object must be string bytes or byte array, not text IO wrapper. Okay, so we have to say, I think, JSON dot load. I think, let me check. Yeah, JSON dot load, not loads. Okay, let me check the data now. Yeah, so we have read the data. We have to use JSON dot load method, right? From the JSON library and pass this file object. Right? This file object is basically reading this file, and then we are reading it as in a JSON format using this JSON dot load. Perfect. So this is my JSON now. If I check the type of this, right? It is saying it is a list, right? Because we understood that this is a list, and within list we have multiple JSONs. Great, great. Okay, so I'll just come back here. So if I just say 0, 0 means give me first element of my list and I enter. So this is my first order, right? Similarly, if I say order 1, this is my second order, right? And then if I say 2, this is my third order, right? And in each order, we can have multiple products. So for example, for the first order, if you see, there are two products, product ID P01 and product ID P02. Great. Now, if you remember initially what we did, if I can go back here, this is the format that we need to create, right? Once I create this kind of format, then I can put it in a pd.dataframe method and create a data frame, right? So we will create data in this format. So we will convert our JSON data in something this format. So I'll show you how and how we will do it, right? So let me go down. Okay, so I'll just, sorry, my bad. Okay, yeah. Okay, so what I'm saying here, I'm saying name is Sumit Rahul Ankit, right? So this is row first, Sumit, 25 age, 25,000. So this is for first row, this is for second row, this is for third row. So what we will do, we will read this JSON, complete JSON, right? And we will create one column for each of the columns. So for order ID, I will say order ID and pass all the order IDs here in the list. Similarly, I will take age, right, or let's say order date. So that will be second key, and I will pass all the order dates here, right? Similarly, for each of the column, I will create here, right? Now we have to create three tables. One is order table, one is customer table, and one is product table. Now let's identify in each table what columns we need, right? Then only we can proceed. So let's say orders table. So in orders table, I will have order ID, right? So let's write it down. I'll write like this. We need order ID. Okay. Order date. Perfect. We need order date. Next, we need a total amount, right? This will also go in orders table. Correct. So we have order ID, order date, total amount. Now this customer information will go in customer table. Now look at the products. So product ID will again go in product table, product name, category, price, quantity. But if you see, quantity should go in order table, right? Because it cannot go in product table, right? Because in product table there will be one entry of this product, right? But this quantity can be different for each order. So this quantity is associated with order, not the product, but it is within the product key value pair, which is fine, but we need to extract it and get it, right? So we need quantity, right? So just quickly check order ID, order date, total amount, and quantity. These columns will be in orders table, right? Let's look at the customers table, right? In customers table, we will have customer ID, right? Then we will have a name, then we will have address and email. Sorry, email is first, right? Great. Great. Now let's look at the products table. So we have products, right? And products table we have product ID, we have name, category, and price. This is the product price, right? So that's it. Quantity is there in my orders table. So this is all we need. So we need to create three tables with these columns. So let's start. Okay. So now what we will do, we will create these three tables by extracting data one by one. Okay. So we have this data now, as you know, where we have multiple orders. So what I will do, I will run a loop over it, right? I will run a loop over it and create a separate list. One list for orders, right? This is how it will be. One list for age, not age, order date, and then so on and so forth. So I have to create multiple lists for each of the column in my table, right? So first what I will do, I will define an empty list, right? So order id equal to empty list, then order date equal to empty list, and then total amount equal to empty list, and then we have one more quantities, right? Quantity. So these four lists I need to create. Once these lists are there, I just have to pass it in pd.data frame in this format. I'll show you, don't worry. Okay, so what we will do, I'll run a loop. So I will say for order in data, right? I am saying order because when I run a loop, each order will go one by one in this variable. Perfect. Now I need quantities also. So I have to run a loop in the products list as well. So I'll say for product, so it is a nested loop. Product in, right? And within this order, we have this products key, right? Great. So now once it is there, so from this order variable, I can get order ID, order date, total amount, and from product variable, I can get the quantities. So I will say, so now I want to add element in this order ID. So I will say order ID dot append. So append method you will use to add a element in a list. And what I want to append? I want to append order ID. Right. So in order I will have this information, and from there I am getting order ID. Similarly, so let me just copy paste this. So I'll say order ID dot append this, then order date. This is the another list. Dot append order date. Then I will say total amount, dot append total amount, right? Then quantity dot append quantity, right? But this quantity is not coming from order, right? It is coming from product. So I'll say product. That's it, right? So now I can say, so I have all the four lists ready. I'll show you later as well. But I can simply say df underscore orders equal to pd dot, so in the same format we have to create, set pd dot data frame, right? I have come out of the loop by removing the indentation, and then I will pass a key value pair, or you can say JSON here, right? So in the JSON, first column I want is order ID, right? And the values for this will be this list, right? Second element will be order date, right? You just have to remember this is how we gave, right? Column name and the list of values. Column name, list of values. Salary, list of values. So same thing I am doing. This is my order date and list of order date, right? Then next we have total amount, right? And the list of total amount, right? Then we have quantity and list of quantity, right? And then it should create a data frame for me, right? So let's see, will it create or not? So I'll just try to print it. Okay, if you see, the data frame is created, right? So if you see, for the first order we have two rows, right? Because there were two product in it, and for each product we have the quantity. Okay, we missed something, right? Now in orders table, we should have other columns as well. So for example, in orders table, let me show you the data again. I think we missed it. That's okay. We will fix it quickly. So in orders table, we need the product ID as well, right? Because once I create the product table, I need product ID to join with this product table. I need customer ID as well in orders table, right? Otherwise, how I will join with customer table? So we need two more columns, right? So let's fix it. So we will just fix it here first, that we need customer ID as well as product ID. Right? These two columns I need in orders table as well. Otherwise, I will not know that which customer has placed which order or which product ID are part of which order, right? So let me take that quickly. So I will say I'll create customer ID equal to empty list and product underscore ID equal to empty list. Okay, so product ID will come from the here from the product list, right? So I'll say product ID dot append product ID, right? Now we need customer as well, so maybe I will take customer here, right? Here I can take. Okay, so I will have to say order, sorry, customer ID dot append, right? And this is coming from order. So order. So if you look at the data again, where is my data? Here my data is, right? So within order I have customer, and within customer I have customer ID. So I will have to reach customer first and then customer ID. So I will say order customer, and from customer this is again a JSON. It will be customer ID. Right? I hope this should work. Let's see. So just remember from order I reach to customer, right? I'll show you again. This is my order, right? And within order I am saying go to customer, and from customer again give me customer ID. Great. Now I hope this should work. Let me get these two columns as well. So I will say let's put at the appropriate place. So I think order ID, order date, customer ID we can put here, right? So I will say customer ID and customer ID, right? And then we need total amount is fine. Let's keep product ID here along with quantity. So we will say product ID equal to product ID, right? That's it. Let's run this. There is some error. Okay, we missed the comma here and one comma here, and this comma we can remove. Perfect. Now if you see, we have everything. Order ID, order date, which customer placed the order, total amount, product ID, quantity. Now if you look at the first order, order ID 1, right? We have two rows. Why? Because we have two products in that. If for order ID 2, there is only one product, so there will be only one row, right? So this is how we can do it. And this information will repeat. Order ID is same, order date is same, customer is same, total amount is also same. The only thing is product ID is different and quantity is different. So we will have to keep data in this granularity only. So this order table looks fine, right? Now we will not load the data in MySQL. Let's create other tables as well. So we will create customer table and product table as well. And then we will load all the data together in MySQL. Great. Okay, so what we will do now, we will create product table as well, right? So what we can do here only we can create the product table as well. For product table, what I need? I need. Let me just remove this output. So I'll just take this. Okay. So for product DF orders is fine. So I'll just remove it. Now for product ID, I need all these column. Product ID, name, category, price, right? So I can create list here itself in this loop. I don't have to write separate loops. So I will say product ID, product name, right, equal to empty. And then I will say product name, category, and price, right? So category equal to empty and price equal to empty. Perfect. So here I will get all of that information. So I will say 1, 2, 3 we need. So we have product ID, then we have name actually, right? So product name, in this the column name is name, right, in my JSON, right? And then category dot append category, and then I have price dot append price, right? So it will give me price. Great. Let's get the customer information as well. So now for customer, right, if you remember, for customer we don't have to run a loop on the product table, right? Because customer is outside of product. So we don't want to repeat this information, right? So what I will do before the product loop, I will get the all the I will create list here, right? Before the product loop, right? Because I don't need any information from product table to create the customer table, right? I needed information from product table for order table because I needed the quantity, but for customer table I don't need any information from product, so I will keep it out, right? So I will say, so let's create more list here, empty list, and I will say customer id, right? Customer id is already there, right? Customer id is already there. We will say customer name empty list, email equal to empty, and what else we have? Address, right? Address empty. Perfect. So let me write it here. So maybe I will take this customer one, right? So we got the customer id from here. This is what we need. Okay. So we have customer id dot append order customer, and from here I need uh, customer id. Okay, so customer id will be repeating here, right? So what we can do, we can get another customer, for customer table, right? So let me do this, because there it will be repeating, right? It will be added multiple times. So what we can do, we can get another customer id, right, for customer table. So I will say cust id, let's say, for now, right? Not the best naming convention, but for now it is fine, right? So I will say cust id dot append customer id, right? And that's it. 2 3 4. Okay. Next is customer name, right? And I need name from here. Great. Then we have email, right? And append email from here. And then we have address, right? And we'll say append address from here. Perfect. So we have cust id dot append customer id, name, email, address. Perfect. So we have everything. Let's create other things as well. We will have to make some changes. I'll tell you what. So just hold on. So we will say df underscore products equal to pt.data frame. So we will have product id here. So let's take this on the top. So we have product id, and then we have product name, category, price. So let me copy this. So we'll say product name, category, and then price. Okay, perfect. So I will remove all of this, right? Let's look at df products, if it is fine or there are some issues. There will be some issues, but for now, let's see. Okay, so this looks fine. We have loaded all the data. But if you there are duplicates, right? P01 is here, then again here. It is because there are multiple orders for each order, and we have not removed the duplicate, right? So we will remove the duplicates from here later on. But let's create the customer data frame as well. So we will say df customers. For customers also we will have duplicate, right? So we will see. So we have customer ID, right? And then we have customer name, and then we have email, and then we have address, and this is address. Okay, and let's see if this is fine or not. So I will run this. There is a value error. It is saying all arrays must be of same length. Okay, my bad. So we will have to use cust ID here, because in this customer, in this one we have more values, right? Because it is within product. So we will use cust ID. That is why we created one more variable. Perfect. So now it looks fine, right? But here also we have duplicates. See, John Doe is there multiple times. Great. So all data frames are done. The only thing is df orders is fine, But for DF products and DF customers, we have to drop duplicates, right? We don't want multiple values to be inserted in my dimension table in my MySQL, right? I just want 101 only once. So what we should do, we should drop duplicates. Now my question is, based on what you want to drop it, right? Because it might be possible that here, let's say email id is this, but later he updated his email id in when he placed another order, right? So what we want the data from the latest order id, right? We don't want to randomly just remove duplicates. We want whatever is the latest, that we want to keep. So what we can say, we will say that keep the last record when you remove duplicates, right? So I will say df customer dot drop duplicates, right? Okay, but keep equal to last, right? I want to keep the last record. So if they are exact duplicates, right, exact duplicates, but again there is a problem. If I do it, right, if I do it, what will happen? If let's say this email id is changed, then it will not be a duplicate at all, right? It will not be a duplicate. So I will say based on customer id drop duplicates, right? So subset equal to customer id. So I am saying drop duplicates based on customer id. So if customer id is two times 101 101, right, drop it and keep the last one, right? So it will keep this John Doe second one, or we can see that index 3. Here there is no change, so we will, for us it is a pure duplicate, but in future it might be possible that this value is different or address is different. So I want to keep the last one, right? So 3 will be there, or maybe John Doe one more is there, so we will have index 10 for John Doe, right? So let's see what will happen, and we will say in place equal to true, true, right? And then we will print df customers. Perfect. Let's run this. And now you see we have only 11 rows and all of them have the unique value. For John Doe, if you see, we have kept the latest index value, right? 145. Some indexes are missing in between, which is fine. We don't care, right? But now we have unique values for each customer ID from 101 till 109 or whatever, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9 customers from 101 till 109. Perfect. Great. So our DF customers is ready. Similarly, for DF products, right? For DF products, let me copy this. Right? I will say DF products dot drop duplicate subset based on product ID, and again keep the last value, right? And in place equal to true. And let's look at the DF products now. So if you see, we have only 5 products, right? So we have so many duplicates in that we have kept the last value from the table P01, 02, 03, 04. Now our all three data sets are ready, right? Now our all three data frames are ready. Sorry, I wanted to see the orders. Orders is also ready. All we need is we need to just load this data into SQL. So what we will say, we will just take this, right, and we will run it for all three tables. So let's come down here, and okay, so these tables are currently not there, so I will just say replace, so that it will just create the tables, right? So I'll say replace, and then df underscore orders, right? This will go to orders table, right? Then I have df underscore products. This will go to products table, and then we have df underscore customers, and this will go to customer table, customers table, right? So we will have three tables created, right? Df customers, df products, df orders. So I'll just run all of these three statements. It is all done, and let's, so it is showing there are 9 customers. For the last command it is showing the output, which is fine, but we will see the data now. So select star from orders, right? And this is the data we just created: order id, order date, customer id, total amount, product id, and so on. Then we have products table. It will have, I think, 5 rows. Right. It has the 5 rows. It is in the same order what we see in the data frame. Right. And then we have customers table. So we have the customers table also created. Okay. Great. Awesome. Now, if you want, you can do all kind of analysis. So, for example, let's say you have this products table, right? And you want to see product-wise total sales, right? For each product, what is the total sales? Or within each category, what is the total sales you have done, right? So you can just select star from orders O inner join products P on O dot product ID equal to p dot product underscore id, and we will say, let's say you want category p dot category comma sum of o dot total amount as sales, let's say, and group by category, right? So you can do all kind of analysis using SQL on this data, right? Perfect. So for electronics, this is the sales. For furniture, this is the sales. Now your three tables are ready, and you can run all kind of queries, right? So this is a good project, small project to practice pandas, right? What we did, we also should know how to run loop, right, and how to append data to list and how to create data frames. So all of those things we did in this small project, right? And then once it is done, we have just loaded the data, right? Now there are a lot of other things that you have to do, right? What will happen if there is new data coming? How you will do incremental load, right? So you have to figure out this can be your extended project, right? So if new data is coming, then obviously you don't want to duplicate the product. So you have to find a way that you delete the existing product. If in the new data, let's say P04 is again coming, so you delete from the table and insert the latest data. Similarly, for customer, you will have to identify if there is any new customer, existing customer coming in your new JSON. So you have to do changes accordingly in your dimension tables, right? Products and customer dimension table. And in orders, it is just a append. You have to keep appending the new orders data. But for products and customer table, you will have to see that existing products you will have to replace, right? Latest data you want to have for each product or each customer, or for the new customers in your new JSON, you have to insert. So this might be your extended project that you want to complete it. But I think you can do it now if you understand all of this. Okay, great. Hope you like the video. Please make sure you like the video, hit the like button, and share with your friends, right? Because it takes a lot of effort to create these big videos, and I need all of your support. Thanks for watching. Have a good day.